The rectangular vacuum chamber is fixed inside the magnet. A system of large vacuum pumps is installed to evacuate the 25 cubic meter chamber so that protons can circulate unimpeded. This is followed by the installation of two D-shaped electrodes inside the vacuum chamber. Together with these electrodes, a radio frequency generator creates the electric fields. That accelerate protons from a source inserted in the center of the vacuum chamber. In summer 1957, the synchrocyclotron is ready, and CERN'de's first accelerator comes to life. The purpose of the synchrocyclotron is to produce and study new particles. Before accelerators were available, such particles could only be observed in cosmic ray experiments. The new machine accelerates protons to 80% the speed of light, producing millions of new particles when those protons collide with a target, giving scientists the opportunity to make systematic measurements. Operation of the SC requires a sequence of actions. Massive pumps extract the air from the vacuum chamber so that protons do not collide with gas molecules during their acceleration. In the proton source, hydrogen gas is ionized and a cloud of protons is injected into the middle of the synchrocyclotron. The accelerator makes use of magnetic and electric fields. The magnetic field is produced by a current of 1,800 amps flowing through the coils of the huge magnet. Two D-shaped electrodes with opposite polarity are fixed inside the vacuum chamber in the middle of the magnet. Protons have a positive charge and are drawn towards the negative electrode as they traverse the gap between the electrodes. The magnetic field forces them to follow a circular trajectory, and they return to the gap after one half turn. Meanwhile, the radio frequency generator reverses the polarity between the two electrodes. The protons are now attracted to the opposite electrode and gain more energy. This process is repeated over and over again. Every time the protons make a half turn, they are whipped around faster and the radius of their path increases. After more than 100,000 turns, they have reached an energy of 600 million electron volts and move at 80% of the speed of light. They are now close to hitting the target, and the first experiment can begin. In 19